You're breathing stiller.
Okay, folks, remember what I said?
I can see.
Right. Liquid nitrogen has to be brought down to about negative 321 degrees Fahrenheit to liquefy it. Okay. And it's the same nitrogen that's floating around you right now, about 70% of the air. Okay. But when they liquefy it and they put it in this container called a dewar, named after the gentleman who invented it, you'll notice that just at room temperature is warm enough to cause this stuff to boil. Okay. So yes, I am holding a boiling liquid in a beaker in my hand right now, and you can kind of see how it's bubbling and spurting around. And if I pour it onto the floor, which is warm, as soon as it hits, it vaporizes. It's gone. Now, you can see how cold the beaker is. Yes. Now, I wouldn't stick your tongue to the bottom of this or anything.
But I want to.
I wouldn't. I really wouldn't.
Oh.
Right. That's negative 321 degrees Fahrenheit. Now, got a bowl full of balloons here. What happens to gases when you cool them?
They expand.
No, they condense.
They contract. They expand. They do not expand.
Come on.
I was thinking of boobs. I said boobs.
Wow.
Oh man.
Trust me, it's not going to require that much.
I was thinking of boobs. This sorbet is not even so great.
Get down. It does kind of sound like Rice Krispie treats, doesn't it?
We're going to have to do another take of this one.
No, I won't. Now we got that on tape.
That's why you're a chemistry teacher.
I'm also wearing gloves here. But you can see with the liquid nitrogen we've got in the bowl here, all of those balloons condense down to a very, very small volume.
Blowing back up?
They will blow back up. In fact,
Oh my gosh, that is
Can we touch one of those?
one of them yeah, the liquid nitrogen does kind of freeze the rubber of the balloon and make it a little bit brittle. But you can see where they all blew back up.
Look at the table.
What
It
of them?
froze.
Yeah. Yeah, well. Okay, right here on the bowl, you can see the metal got cold enough for it to retain a lot of that cold. I shouldn't say retain cold, but you know what I mean. Now, this one's kind of cool. I got a ping pong ball here. And what I've done is I've punched two holes in the ping pong ball kind of at diagonals. Now what happens to a gas, what happens to the pressure of a gas as it warms up?
It blows up. Like a boom.
It expands. The volume's going to expand, which means what happens to the pressure? The
Is it
pressure
gonna blow
also
up?
increases.
So then it goes pop. Does that burn touch your skin?
It will, yes.
Not very long.
If I were to get this on my skin, it wouldn't feel real good. So I've taken this ping pong ball here, and I'm going to go ahead and try and line it up so that one of the holes I punch is actually down in the liquid nitrogen.
What do you
I hope I got get enough liquid nitrogen in there. What I'm going to do is I'm going to dump this on the floor.
Oh, that's cool.
And notice that as the liquid nitrogen expands, what's happening to your ping pong ball? It's spinning because as the gas expands and the pressure goes up, that gas is shooting out through the holes I punched in it,
Look at Steven.
and that makes the ping pong ball spin. And again, you can see just how cold the ping pong ball is.
Okay.